Oh, okay. Looks like we can get started. All right. Well, thanks everybody for joining. Oh, start in 10 seconds. Okay. Okay. Start now. All right. Well, thank you everybody for joining us today. We'll go ahead and jump right into it. So this workshop is an introduction to adversary emulation with Prelude operator. So today what we're going to be going over is a little bit of the basics associated with adversary emulation. Some of these things and topics you may have seen before, but we want everybody to come out of this with a good baseline of what it means to do some basics of adversary emulation. From there, we're actually going to dive into the Prelude operator platform, and we're going to put some of that application to practice. So we're going to go through the process of installing Prelude operator, becoming familiar with the tool, and learning how to start an agent, deploy that agent, and then we'll actually run through a very basic campaign running against your local system. So for those of you following along at home, you should be able to, if you're on a Windows system, a Mac, or a Linux system, you should be able to follow along with us, no problem. Without further ado, we're going to go ahead and dive right into it. So a little bit of background for the speakers today. My name is Alex Manners. I go by @KyberSpache. I'm on Twitter, GitHub. I'm a security engineer at Prelude, and I run the security engineering team here. My background is offensive and defensive cyber operations with the U.S. Air Force. I was also one of the lead developers on the MITRE Caldera version 2 platform, where I worked alongside David Hunt, who also works at Prelude, and we built a lot of different stuff there. I've worked in various number of other places, but right now I'm going to hand it over to my other speaker today, which is Chris.
Hi, my name is Christopher Willis. I go by Xanthanus on Twitter, all your social media sites. I'm a security researcher here at Prelude. My research interests are mostly in adversarial AI. I've been doing a lot of TTP change in that recently. Automated program analysis, so fuzzing, concolic analysis, SAT solving, things like that. And then offensive cyber tool development, so things like building operator. My professional work has been within academia, U.S. Department of Defense contracting, both small and large, and I also worked for Department of Energy National Lab Space as well. I was a technical lead on AFRL's Black Badge program, which facilitated DARPA Cyber Grand Challenge, which is c0c0n. It was an automated program analysis competition where you had 8 teams that tried to automatically create like adversarial automated program analysis, like competition, like a CTF. So I hand it back over to Alex.
Great. So what are we talking about today? Basically, what we're going to talk about is we can use freely available information online and emulate components of APT kill chains. And what we essentially want to establish is what we call a continuous defensive evaluation process. We want to do small iterative actions over time that can help us increase our defenses of a system. So we're also going to talk a little bit about some philosophies, which are training the way you want to fight. So which means you will probably want to do your testing in production and actually attack the systems that are running in production. And the most important part of this is basically keep it simple. We want to take very small steps and then assess the efficacy of those steps. So where do we start? We're going to talk a little bit about what an adversary actually is. Then we're going to jump into how you would begin to understand your relevant threats and where you would go to find and parse some of that cyber threat intelligence. Then we're actually going to select a platform to launch those attacks. Today we're going to be using Prelude operator. From there, we're going to design and operationalize a basic adversary profile. And then we're going to go through what I consider the most important part, which is closing the loop. So we'll do a lessons learned, how we can begin to generate a lesson, what we call a formalized lesson learn, which is a standard way that you can assess how well you've tried to meet a goal. From there, we'll discuss a little bit about establishing a continuous test and evaluation cycle. So this is obviously very basic, and I'm sure many of you have seen this, but we're just going to go through it very quickly. So what actually is an adversary? It could be basically any malicious threat actor. It could be somebody who's skilled, unskilled, and literally everything in between, from script kiddie to APT. And how that is relevant to what we're going to do today is we can apply varying levels of complexity into our adversary emulation campaigns. We can do stuff that is as basic as script kiddie based attacks, and then we can also implement more advanced implants, more advanced attack strategies into our overall adversary emulation kill chain. We're going to keep pressing forward because, again, today we want to dive into the actual tool. So let's talk about understanding your relevant threats a little bit before we actually jump into Prelude Operator. So when I say understanding your relevant threats, the questions you want to be asking yourself are, who would be targeting me? Why would they be targeting me? What are their capabilities? What are their TTPs? Very common phrase that we use. And then how would they actually attack you? And there are two standards that you should be using when you're creating this assessment. What is their most likely course of action? And what is their most deadly course of action? So the most likely course of action is, what is a threat most likely to do against your organization? And what is the most likely outcome of that? The most deadly course of action would be if they were to do the worst possible thing to you, what would that be? And understanding those two components related to that threat is how you can begin to develop an overall threat profile. And the goal here is you want to identify your organization's crown jewels and your center of gravity. So what are the important core components of your business, and how would a threat target those core centers of gravity, and get after those, quote, crown jewels? And all of this eventually drives to your overall organizational risk. So we'll keep pressing forwards. So all of this underpinning everything that we were just talking about is cyber threat intelligence. And we're not going to dive deep into this today. I just want to give people some resources that we're going to use later on in this workshop to actually build our threat profiles. So CTI, according to CrowdStrike, is essentially the data that is collected, processed, analyzed to understand a threat actor's motive, targets, and behaviors. And I like to put them into three top-level bins. At the highest level, you have what's called strategic cyber threat intelligence. And that would be a threat actor's overall targets and objectives. What are they, at a very high level, trying to accomplish? Below that, you're going to have operational CTI. What are their ongoing campaigns and operations? What are the things that they are doing now that encompasses a lot of their tactics? And that's the lowest level, tactical CTI. What are they actually doing at that hands-on keyboard level? So how do we use it? Basically, what we want to do is we want to find a threat that is known to target your industry and understand how they operate at a high level. From there, we're going to find past and ongoing campaigns associated with that threat. And then we're going to learn what that campaign looked like and how they actually operate. From there, we're going to dive into an operation and see how they build the tools that they use, how they emulate, or how they actually apply their TTPs. And then we can extract some of those and begin to emulate discrete techniques that they use. Just making sure I have the group chat pulled up. All right. And in order to drive after these top level objectives, there are some resources that are provided. and we'll talk about these during the actual workshop component of this. But one of the most important ones is this CISA alerts page. So the U.S. government offers basically a real-time feed of alerts that are being put out by this organization called the Cybersecurity and Infrastructure Security Agency. It's a mouthful. But this is a good place to come and get a lot of different kinds of CTI, and to as a person who only really has access to open source intelligence, this is a great place for you to go to and get an idea of what's actually happening across a wide spectrum of industries. So this is what we're going to use during our workshop today to drive at some of the TTPs, some of the campaigns that we're going to try to put together after we have a good baseline for understanding how to use Prelude Operator. So we just did that. We went to that CISA site, so we're going to press on. So when we talk about attack platforms, there are a large number. If you go onto C2 Matrix, there's, I think, 90 now listed on the C2 Matrix. Everything from open source tools like Sliver, Caldera, to paid platforms, and everything in between. Today, we're going to use Prelude Operator. So without any further ado, I'm going to hand it over to Chris, and Chris is going to walk us through the basics of Prelude Operator. And right now is the time where you would want to go ahead and download Prelude Operator and install it so you can follow along. To do that, you can just go to prelude.org, and the website will look like that. Just go to prelude.org. Click on download, and then you should be able to download Operator 1.2 for your preferred platform. With that, I'm going to hand it over to Chris to do the basics of getting started with Operator.
Yep. So let me try to reshare here, see if I can take control.
Just click on the share button. There you go.
Cool. So as Alex was saying as well, to back up just a minute, while there's a lot of C2s that are available, we integrate with some of those. So we do have integration with Sliver, don't we, Alex? And then we also have, so the Atomic Red Teaming platform can be completely integrated into Operator. So we've got a lot of integration stuff. We'll probably integrate a decent amount with Caldera as well at some point. So after you download Operator, you end up in a window like this. So this is where you start out. There's the so we have these tabs here. They're on the left-hand side. There's Operate, Train, Editor, and Reports. And then down here at the bottom, we have plugins, docs, and to the account. Now, so every account, so you don't have to run with an account anymore. So you don't have to sign into an account, but it keeps all your settings. It's a good thing to do. And then you know that you're signed into the account section when you have this green logo here down at the bottom. So if we're at Operate, Operate is basically how you would get to your agents, how you get to your ranges. So ranges are basically, think of that as more of like a campaign almost. So you could put multiple different agents into your into a certain range, and so through that range you can connect to multiple different target boxes. And then we have right here we have create new chain. So chains are basically to go a little bit more in depth. So we have TTPs, or just Ps, the procedures, and then we have so you go from the procedure, so what you want to accomplish on the box, and then we have adversaries, which are just a chaining of procedures that we then create into. We basically put all those things together to create an adversary. So an adversary can do multiple different things. So if we go into, say, bigger discovery, for instance, we hit the edit button. We can see multiple different procedures that we have within here that will basically be executed within the agent. So let's talk about agents for a second. So if we go up here at the top, we can basically select any agent that we need. So this will go depending on the platform that you're on, depends on where it goes. For Linux, it goes into your temp folder. So if I wanted Numa for Mac OS, for instance, I could just click on here, and then it automatically gives me a compiled version of that. So that went to my temp folder, and then I can pull that wherever I need to. So we have multiple different agents within here. So I would say our bread and butter agent is the Numa agent. And so Numa is a Go style agent that works on all platforms. So it works on Mac OS, Windows, Linux. We have Schism. Our Schism agent is a Python agent. And then we have a community-driven agent, Nicodemus. So that's also it's a NIM implant that works with all platforms. We have the Hush implant, which is JavaScript, JXA, it's Mac OS. And I think we have further plans for that to be on more platforms later on. And then we have our Numa extended agents, which is more of a framework style agent. It's an upgraded agent that's for our professional license chain. So there's ways that you can go in and configure encryption, configure network settings, tons of different configuration options within here. And so you can go on different ranges. I had this, for example, was an agent that I ran testing out some modules. And so when you run a procedure, it will stay within the agent even though it's no longer running. So we categorize green or red as depending on if it's green, if it ran correctly, or if it's still running within the agent. Red means that, of course, it's not running anymore, or it can't connect back to the box for whatever reason. And so we can go back and get a detailed list of everything that we ran within an agent. Or if we have things that we are still in the queue. So say if you had a beacon agent. So a beacon agent is something where an agent over time will connect back to the command and control interface. And so you can use different time intervals in order to push out a procedure. And so if we had anything in the queue for the next beacon, we would see this here at the top. So we have a lot of configuration stuff. Also here, if I go up to the top here, it's like my agent. Oh, I don't think I have access to it right now. So we have this button up here at the top where we can do interactive. So there's two types of ways that you could interact with an agent. You can do interactive mode, or you can do beaconing. All of our implants support beaconing. And then you can go into an interactive mode to be able to do multiple different things at one time live. So if you knew what commands that you wanted to run without being on procedure, you could run those right within interactive mode. So we have training programs within here. So we have intro programming or introduction program. We have our pink badge, which is more of on the IT side. So understanding basically going through the basics, understanding TTPs, the attack framework, things like that. We have some CTF stuff in here, which is more advanced. And a lot of those have to deal with the cloud plugin that we'll talk about here in just a second. And then we have our attack procedures, which is basically understanding the attack framework. And that's a professional license thing. So if you are a professional license holder, you can get our attack procedures training. So within the editor is probably one of the bigger parts between when, as a user, you're going to go through one or two things. You're going to go through either operate or the editor, most likely. So the editor is a big part of our tool. Right within this section, this is where all of our TTPs exist. So we do tagging on certain things. So like for example, Conti, for instance, all the Conti ransomware TTPs are within this Conti tag. And then we have different things that are within here. Say if you wanted things that were for Docker, you could come in here and look at particular TTPs for Docker. So let's just running through a TTP on how it looks like on our platform. So up here at the top left, you would see what executor it's for. So in this case, it's for Linux. And then through this, we can tell that it will run through sh as our shell. And then this would be the command. And so you can come in here and you can edit any of these commands. And then there'll be a save here at the top. So if I was to change this, just deleting this out, you would see, okay, so you could revert back or you could save. So you could change any of the TTPs that are in here and they'll save for any time that you come back. You could deploy the TTP. So this would deploy. If I hit deploy here, I could select my range and then I could select my agent. So in this case, my home is just the local host. And so this is my local box that I could run a TTP on. If I had any agents that were currently running within another system, I could select that agent or the multiple agents that I would have running on, say, that range campaign. So let's say if I wanted to create a new TTP that wasn't currently in our system. You could hit the plus button up here at the right, and then create a new TTP. So in creating a new TTP, we make it really simple. So you go in here, type in the executor. So in this case, if I wanted to do Linux, and this is just an example. So you could do shell, you could do Python, for instance. But if you wanted to do Bash, for instance, totally doable. If you want to do ZSH or Zshell, you can easily do that. So we support any of the shells that are in here. Those are just what we have as an example. You could totally go outside the bounds there. So then we would write our TTP. We would name it, put a description in there, put yourself as the author, of course. Tag it if it deems a tag, and then select the tactic. So the tactics are all mapped. So all of our TTPs are mapped to the attack framework. So the MITRE attack framework, they're all mapped within that. So you could select the right attack framework, or so the right tactic and technique, and then you would hit the save button here at the top right. So reports. Reports. You can select a range. This would just give you basically the ability to see how things run within a graph format. This is part of our professional license, and it gets really interesting once you run a lot of TTPs on here. Mine doesn't look very interesting right now, but you can have different things on how they interact and chain together. Like I said, it gets really interesting once you run a lot of TTPs. So plugins. Plugins is a really big part of Operator as well. And like I mentioned earlier, we integrate with things like the Atomic Red Team tool. So if you wanted to import all of the attack files, for instance, you could do that within our plugin. So click this. You you can't see it on screen, but it basically comes up with a question that says, hey, do you want to download this plugin? You say yes. And it's that easy. So we have different things within here. So you can change how operator looks. We have a navigator basically to display the attack navigator and basically give you like export layers, things like that. We have a toolbox, which is really cool. So what toolbox does, so it will clone and track your basically any GitHub repositories. So it will monitor the GitHub repository. So say if you had any red team tools that you want to keep and keep up to date, Toolbox is an easy way to do that. So you just put in the GitHub link, and it will ensure that your GitHub tools are up to date. We have a Cloud plugin. Now, Cloud is being a little bit different in our new version called 1.3, which it'll be called Connect. But Cloud allows you to deploy what we call redirectors, or the ability to basically redirect an agent's communication. And so you can also make test ranges, things like that. So you don't have to necessarily have to create a virtual machine on a local box. We support AWS, the Google Cloud, and for 1.3, we'll even allow you to select multiple different regions. So again, the ART plugin allows you to import the atomic red team attack files. We have a planner, which is like a built-in engine that basically decides which TTPs run in order. So those you can go into Planner and then plan out which TTPs you want to run as an without like you would do that within the adversary section. So we have Publisher, which is basically the way to send agent results from external databases like Seams or chat rooms, things like that. And then we have the ability to connect within certain Seams. I'm not as familiar with this plugin. Alex, I don't know if you know any more about the Seam plugin.
Yeah, we can loop back to that, but let's press on to the docs here.
Yeah. So we have docs within here as well. Basically just giving you the basics, right? So what Prelude operator is, what is an agent, what is an adversary, what is a TTP. We kind of give you through the basics. And then we have more things, so more documentation that you can find on our GitHub page. And I think that's a good rundown of the tool.
Great. So I'm going to take over the share here. Attempt to take over the share here. Great. So now that we've got a baseline understanding of the tool, we're actually going to go ahead and dive into using it. So the first thing we want to do is come over to this download an agent section. So after you've got into the application, you don't have to log in, by the way. Once you launch Operator, it's going to take you to the home page, and the home page is this Operate section. From here, we're going to go ahead and download Numa. So if you're running on, let's say you're running this on a Linux system, go ahead and download Numa Linux. If you're running this on a Mac OS system, go ahead and download Numa Darwin. If you're running this on a Windows system, go ahead and download Numa Windows. For those of you on Windows, I'd recommend you just, when you download Numa Windows, it's probably going to get flagged by Windows Defender. So I would suggest you turn off Windows Defender for sake of this demo. If you need and you prefer to get a little bit more complicated, you can actually go to the Numa repository on GitHub, which I'm pulling up here. And you would be able to compile a version of Numa using our built-in scripts. which would let you bypass the Windows Defender detection. You would be able to use this garble build, and I will post the link to this inside the conference chat. You would just need to git clone this and then run the go mod commands that I've provided for you here in this README. But we're not going to do that today. Today, I'm just going to download Numa Darwin for my local system. And then I'm going to go ahead and go to my downloads folder, and I'm going to connect an agent. So as we mentioned, it will download to a specific folder on your Linux system. It's going to download to /temp. On Mac, it's going to download to your home directory downloads folder. And then on Windows, it will download to C users public. Once you have the file downloaded, we're going to go ahead and connect it. The way you would connect it is you're going to run it through via command line. So PowerShell, command prompt, or bash equivalent on OS X or Linux. And we're going to pass in a few flags so that we can see what we're doing. First thing we'll do is -debug. That's the one we care about. And then we're just going to hit enter. So by default, the agent is just going to connect to localhost. Again, we're doing everything on localhost, so we don't need to worry about making the agent connect over remote systems right now. We can come back to that later in the presentation. Once the agent connects, you'll notice that you'll get a connection on your home range. Or connection on, sorry, the red range. And when you drop into the red range, you should have an agent. I'm going to pause briefly right here to let people that are trying to follow along. If you have any questions, we are inside the chat for the c0c0n. Feel free to ask questions there, and we will answer them. Just brief pause for people. All right, we're going to continue to press on. So as Chris had mentioned during his overview, there are a bunch of different settings. There are a few things I wanted to talk about in general, but we're not going to dive into them fully here. The first and most important one is this network settings. This is where you're going to control the ports that are exposed by your operator instance. You'll also notice that we are only exposing localhost. So you would need to explicitly share all interfaces if you wanted to use this in a remote scenario. So sharing Quad 0, for example, would allow you to have remote agents connect to your system. I'm going to set that just in case I want to run some remote agents. But from here, you could modify the TCP port that is available, the UDP port that is available, the HTTP port that is available, and the reverse shell port that is available. Up at the top, you'll note this connected to HQ button. You can click and unclick this. If you click this, it's going to take you into offline mode, so you would be able to use this on an air-gapped network or without internet connection. You'll notice in the background, when I did the interface change, it actually caused my agent to disconnect momentarily, so we'll wait for that to reconnect. Then we're going to go through the process of deploying a single already existing TTP so that people can get an understanding of how that would work. As you can see, the agent has reconnected. So the first thing I want to do, let's say I want to run a single TTP. I want to do a single discrete TTP test. So I can jump into editor. From editor, let's say I want to run a discovery TTP. Let's say I want to run a snagging of the broadcast IP. So I can click on this, and that's going to, as Chris had showed us earlier, it's going to give us this basic IF config, pipe to grep broadcast, and this exists for a Darwin platform. So if you're following along on this workshop, go ahead in the discovery section and find one that matches what you would want to use for your local system. So I'm going to go snag broadcast IP, and then I'm going to click on this deploy button. Chris had showed us this briefly, but we're going to actually do this. So up here, I'm going to select the red range, and that's going to automatically select the single agent that is connected in. And then I'm going to click deploy. So what just happened in the background is operator just queues up that action, and the agent will reach out to the C2 server, collect that action, and then execute the action, responding with the data of the results of that task executing. But what you'll notice down here are some automatically extracted IPs. So as part of the automation engine inside Prelude Operator, it's kind of similar to the automations you would see in MITRE Caldera. We're able to extract pieces of information from the data that you're actually generating on a target system. So here we have gathered a few variables. The variable is IP T1016 because we ran a T1016 MITRE attack tactic, and it grabbed various IP addresses. So these would be IP addresses that we could use in the future, along with some context. So I know this is my current local private IP address. If you have, for some of these TTPs, you'll also note there's this training manual over here, which some of them will have free versions of like essentially what would be a man page for a TTP. But what we're interested in is primarily this deploy button, because this is what's going to let us go ahead and run repeated tests. So again, as we mentioned, the point of this talk is kind of how you can do this in a simple way, but how you can do this in a simple, repeatable way. So I can run that same attack against that system, and it's going to produce essentially the same exact result every time. So I can do this as many times as I want and begin to tune my detections. And over time, the tuning of detections can help us implement that continuous defense cycle we talked about. Now that I've deployed 2 TTPs, we can go back to the operate section, go to our red range, and now we'll see that we actually have, as Chris had showed us earlier, those outputs from the agent. So operator is going to basically keep a perfect log of all of the actions that you have run on your agent, so that you'll be able to track the actions that you're doing on a target system, and make sure that you're not running anything that would be secretive in any way. So that's the basics of running a very simple action from editor using the deploy situation. And again, we can run basically anything for your given platform. I was running the snag broadcast IP, but right now I would take a few minutes just to look through the editor section and look at a few of the different TTPs and maybe try and test and deploy some of the TTPs against your system. I'm going to pause right here for approximately a minute so that people have a minute or two to dive into editor, search through it a little bit, and flip around the interface. While they're doing that, I will answer any questions that are coming from the crowd. I will also, in the background, be looking through TTPs and running various tests. All right. Now we're going to step it up a little bit, and we're going to talk a little bit about chains, which is what Chris had mentioned earlier, chains being essentially clusters of TTPs. So first, we're going to take a look, for those of you, again, following along, drop down to this File Hunter. When I run File Hunter, if I click on Edit, I'm going to see the TTPs that have been added to this adversary profile. And what you'll note is this one will actually run across platforms, because we have, for each of the various platforms, for Mac, Linux, and Windows, we have TTPs that will run on all of those platforms. So what this chain will do is it's actually going to automate the process of doing a local discovery, followed by creation of a staging directory, copying all of the files into a staging directory, and then compressing that staging directory for exfiltration. And underpinning all of this is the variables that Chris has noted in the live chat. So looking at these TTPs, you'll notice this like variable language. You'll notice various components of these commands have this pound squiggly bracket with some kind of verbiage here. These are essentially TTP templates, for lack of a better word. And we're able to render in knowledge that, remember that IP T1016 that we saw? We're able to render in this IP T1016 into a future command. So looking at File Hunter, if we had a directory T1074 TTP, or variable that we've learned, we would be able to then generate this command. So again, for those of you following along, go ahead and select File Hunter, and then go ahead and click on make sure you're on your red range, and go ahead and click Deploy. You'll note you're going to get a bunch of things will get queued up, and then it's just going to kind of power through all of the TTPs that have been added. Now, if we go down and we take a look, the last one that we ran manually, that I ran manually, was this avoid logs. So I did that snag broadcast, and then I did this avoid logs. And then I ran that automated kill chain. So let's take a look at what that did, and then use this as a way to understand how we can build our own kill chain. So the first thing that happened is we created a new directory. And what we can see here is I just ran a simple like mkdir-p /temp stage, and then we echoed out that temp staged. From there, we were able to parse out some information. We parsed out a file T1074 and a directory T1074. As I had mentioned, this directory T1074, looking at this actually matches what we saw in that template command that I was showing you earlier, that pound squiggly bracket T1074. So going down, we can actually see that operator is telling us what it can be chained with in the future, compressing a staged directory and also staging collected files. So what we'll see is we're now going to run this find recent files command, and that's going to grab a bunch of files for us. What are the recent files that have been used by this file system? And then from there, I didn't actually task out these TTPs. These TTPs were generated. So it's going to stage all of those files into that directory. So we'll note, like, I downloaded Numa Darwin to run this agent in the background, right? Well, operator went ahead and said, okay, well, I discovered that Numa Darwin. I'm going to move that into that directory that you just created right here. So I found the recent files, Numa Darwin. I know that this temp stage directory exists. So let's go ahead and start moving those files, copy Numa Darwin into that stage directory. And you'll note we found 4 different files, and it went ahead and it tried to stage all 4 of those files into that temp stage directory. And not all the commands will be as successful. You'll get a red icon when a TTP fails, and it can fail for any number of reasons. But finally, what you'll see is now that we've staged all of this information, we're actually going to go ahead and compress that directory. So we run this tar-p-zcf, and it's going to compress that temp stage directory into a tar-gz. And then we have this tar-gz file available for exfiltration. We didn't do the exfiltration component of this, but we do have other TTPs like file.io exfil or collect an artifact over HTTP that you could run to then complete kind of the exfiltration component of this kill chain. So those are, in a nutshell, the basic components of running a discrete TTP, getting your agent launched and running, and diving into the file hunter and how you would actually run multiple TTPs as part of a automated kill chain. So from there, I'm going to jump back into the slide deck real quickly, but I'm going to give people an opportunity to run that file hunter kill chain briefly for 1 minute. And then we will dive back into the slide deck where we're going to talk about how we can make this relevant and how we can begin to extract TTPs associated with some kind of threat, and then begin to build our own TTPs in editor, add those TTPs to a profile, and then run those TTPs. All right. So really quickly, I'm going to go ahead and log in because I'm going to be doing some of the training stuff later. So this training program up here, the introduction training program, in order to actually do this, you have to create an account because we have to be able to track training progress. You can still go through the flags and take a look at them. So the introduction training program is a great way to familiarize yourself with how the Prelude operator platform works. And it'll do it in a capture the flag style format. And what that means is you're going to have to read through the documentation. You're going to have to connect agents. You're going to have to write new TTPs. You're going to have to modify new TTPs, and then actually submit those as flags in order to accomplish the training program. All right. So with that, I went ahead and I logged in with a demonstration account. So this will let me complete the training program and do various flags. All right, so we're going to jump back into the slide deck. Again, we don't want to spend too much time on the slides because we want to focus this on actually building stuff and running these attacks. So next thing we're going to do is we're actually going to just at a very, very high level, we're going to step through just finding a threat actor that seems interesting. Then we'll go ahead and find on that c0c0n page maybe some information related to some techniques that have been used by them in the past. Then we're going to build that into kind of a similarity of a threat on Prelude operator. We already have our agent deployed, but we're going to then run that locally against the system. We don't have a way to do the response side of this right now, but then we'll generate lessons learned. So I'm going to leave this up over here so we can kind of have this as our overall plan of attack. But as I mentioned, we want to check out this CISA alerts page, and we have some ransomware attacks and a whole lot of options here. But let's jump into this APT40 because I believe they have some technical details. So as we can see here, APT40 has used a variety of tactics and techniques. So we can go ahead and use this one, and we can see that they have the broken down by tactic and technique, MITRE attack tactic and technique. We can extract some of these, search for ones that might exist inside of operator, and put those together in operator into a kind of similar to an adversary profile, and then run that automation against one of our agents to do a very basic emulation of this kind of threat actor against that target system. So let's go ahead and do that. So we found a relevant threat actor, and this seems to be high enough level that it covers not only our strategic level, but it brings us all the way down to the tactical level, and it's telling us the MITRE attack techniques that are being used. So we can use this instead of going and finding a discrete source for that particular tactical data. So what we would want to do is take a look in here and see what kind of techniques they are using. So they're using steganography, they're using API keys for Dropbox accounts, protocol tunneling, multi-hop proxies, typo squatting for C2 infrastructure. So they're archiving, encrypting, and staging collected data, and remotely exfiltrating it over a C2 channel. So already right here, so archive, encrypt, and staging data locally and remotely for exfiltration, and then exfiltrating over a C2 channel. So we actually saw that we kind of ran components of this already because we did do a staging of data. We did everything except for the exfiltration. So let's go ahead and, as a starting point, let's add in exfiltration TTP. And what we can do is we go to this create chain. We'll go to File Hunter, and we'll search for exfiltration. And let's see, we've got a couple different ones. I think there's a file.io. Yeah, so we've got this one. If we search for file.io exfil, actually. So as we can see, this one will actually let us exfiltrate a file to a remote system. So let's go ahead and add that. And then this is actually going to automatically create so it's going to transform the chain into an adversary. And adversary is just, a chain is going to be an automated end-to-end will work type kill chain. An adversary can have TTPs that don't necessarily chain together from input to output. So we're just going to say this is our basic I think we said apt 40. So let's do basic apt 40. And then we'll click save. So again, we added that exfiltration step. File.io exfil. So when we run this now, after this agent does the compression, it's actually now going to automatically try to exfiltrate that to file.io, which, if you're not familiar with it, it's just a website where you can just curl stuff out to the internet, and then it will allow you to exfiltrate it to that website. But let's keep looking at some of this information and see if we can find some other stuff. So there's some resource development. We're not going to dive into the resource development. We're going to stick with kind of assume breach here. So that means we'll also skip over initial access. So they're using command and scripting interpreters such as PowerShell. So we can go into editor and take a look at maybe some command and scripting interpreters, PowerShell type stuff, or Bash or ZSH or whatever is interesting to us that we would want to try and run those techniques. We can see there's some exploitation of software vulnerabilities. So they're relying on user execution of spear phishing emails. And they use a whole lot of other different frameworks, including PowerSploit, which I think we might have some PowerSploit stuff that we can incorporate. PowerShell Empire, I think we have some PowerShell Empire stuff. So we can take a look at some of that. And then, as we had said, they're using steganography to hide data inside GitHub stuff. Protocol impersonation that we looked at earlier. So yeah, let's actually look in the execution and in some of these discovery lateral movement items, and see if we can add any more items to our kill chain. To do that, we'll just go over to editor, and we said we were going to start with execution, so let's take a look at execution. So we have some stuff that we could use over here. Let's see, let's find like get processes. So this one's going to stop processes on PowerShell. Probably don't want to do that. Maybe install PS tools. That's a very common one. So let's add install PS tools to our adversary. That's fairly common. A lot of threat actors use PS tools. I don't think I saw explicitly that they use PS tools. Well, we can, instead of doing that, we could add a PowerCat TTP because we know they're using some PS tools, or sorry, some PowerShell Empire and some other stuff. So what we can do is on this right-hand bar, so we've got this create remote PowerShell with PowerCat. And what we can do is we can click on add to adversary on this right-hand bar. And then I can say add that to basic apt 40. So I'll click add to adversary. And that is now available on that adversary profile that we have been building. So if we go take a look back at apt 40, PowerCat PS1. So this will run PowerCat execution remote IP. And we'll take a look at these facts in a little bit, but these are what are called custom facts. So we'll have to provide a remote server that we want to call back to via PowerCat. Let's keep looking, though. Let's see what other we were looking through execution. Let's go ahead and add installing of PS tools to our adversary. Then we can hop over combination of frameworks. Let's see what discovery we have. I think if we search for PowerSploit, we might get something. So this one, we do have PowerSploit invoke Mimikatz, dump creds, so we can add that one because that seems to be relevant to our threat. We'll add that. We can also, let's say we want to do key logging. So we can add this get keystrokes, and we'll add that to our adversary. Cool, so we've added some PowerSploit stuff. Okay, so I'm actually going to start, because I'm starting to add a bunch of Windows TTPs, I'm going to go ahead and start a Windows virtual machine so that I can connect a Windows agent. But as I'm doing that in the background, I would encourage you to keep looking through Editor, using that, whatever your chosen CISA alert page is, or whatever CTI that you're using as the basis for building your very basic adversary profile. Continue to search through Editor and find ones that are relevant and add those to your basic APT profile that you are constructing. And Chris will take any questions that you might have while we're doing this.
Yeah, and just so people are aware, I cannot type in the stream chat for the Twitch, TV, but I am monitoring that. So if you are on Twitch TV and you have questions within there, I can see the chat room, so I can answer questions in the chat room.
All right, so let's go ahead and open up PowerShell. And we're gonna, as I said, we're gonna drop a NUMA Windows, so I can go ahead and download that. And then I know the IP address because we actually ran that earlier. So we briefly mentioned earlier that you can connect agents remotely. So I'm demonstrating how you would actually do that now. Using Pneumo Windows, you would just pass in the -address flag and then specify the remote address of the system you want to connect to. And you can also optionally pass in a contact flag, and that could be TCP, HTTP, UDP, or gRPC, depending on what you would want to run. By default, it's TCP, but so we don't have to specify anything. And then I can pass in that -debug flag, and then we'll get our Windows agent will connect. Make sure I got the right IP address there. That's optionally, I can specify a range. So I'm going to say Windows range. Did I give it the... There we go. Got my Windows range now, and that agent is connected. So let's take a look at that APT40 profile that we're building. So we can see that we have this PowerCat, which requires this execution remote.ip and execution.remote port. So I could set that up, a netcat listener on my local system, which I will probably do. We still have all of our compressing of stage directory stuff going. We have the copying of our files. We have the creation of our directory, finding of recent files. We're also going to try and run the PowerShell get keystrokes and log it to C key log. We're going to try and invoke Mimikatz and dump credentials. This is just the invoke Mimikatz associated with open source tooling, so it may or may not work. And then last but not least, we'll go ahead and we'll try and exfiltrate to file.io. But we're also going to try to install PS tools on the target system. So now that we've added all of those TTPs, we can go ahead and deploy that against our Windows range. And that's just going to go ahead and start queuing up actions. So while that's running in the background, if anybody has any questions, again, Chris is live monitoring everything, so feel free to ask any questions. As we can see, we've created our directory, and that has been, we found no recent files, so we won't be staging any files. We did run our keylogger on the system. Successfully installed PS tools. Didn't fail to compress the stage directory, but that's okay. So sometimes you'll note, for example, it looks like invoke Mimikatz. We have an old version of the Mimikatz script, so that'll need to be updated, but that's not a big deal. So you'll note I ran this find recent files, and it didn't actually find any files. And what that means is if we take a look at our QTTPs, it means because we didn't actually find any files that have been modified in the last 24 hours, essentially, it didn't actually queue up this staging of collected files to that directory that we created. You'll note you still have that directory T1074 because we created that directory. But when we tried to run find recent files, we didn't actually find any recent files on the system for us to exfiltrate. Because of that, we never went ahead and ran our copy item command. We never generated any copy item commands because there were no commands or no TTPs, or sorry, no files found, so no TTPs were generated. We also, because of that, didn't compress that directory, so we never exfiltrated that directory. Now, this one is blocked for a different reason. So when I say blocked, I mean it's sitting in the queue. It hasn't been sent to the agent as a task. This one is waiting on execution.remote.ip. It's waiting on additional information before it can run this command. So it's waiting on a remote port and a remote IP. So we can actually provide that to our agent. So we know our agent. We can actually come look at those facts. So we want to somehow tell that agent that, hey, there is a remote IP and there is a remote port for you to run. And we want you to send that to like a netcat listener. So we can do that by coming up to this fax modal. And in this fax modal, we'll see various pieces of information. So we'll see this operator.tcp. We'll see this, which is the TCP callback. So if this agent, let's say this agent were to try to connect back to operator, this is the address that it would need to use to connect. And if we go back to our virtual machine where we're running our agent, we'll see that it actually matches the address that we used when we sent it to the NUMA agent. If, let's say we wanted to use UDP, as I'd mentioned, you can use that contact flag, right? Well, you would send it to this listener, the 4545. Let's say you want to use a reverse shell, which I will actually briefly demonstrate. Then you would, over port 3007, send the connection back to operator. Let's say you want to use HTTP, you would just send it to port 3391. And there's a whole like plugin architecture called Cloud and Connect that Chris was talking about that would let you expose like HA proxy redirectors and all of this kind of stuff. So you wouldn't have to manage standing up any kind of like domain fronting or HTTPS, TLS termination, anything like that. You would just click the deploy button and then you would connect your agents to your AWS redirector, which is why we listed AWS as optional for this talk. So what we want to do is turn that off. Yeah. So we want to try to run PowerCat. So I have started a netcat listener on my system on port 4500. Do we have any questions, Chris?
Yeah, I've been typing up questions. So one of the questions was, are these activities safe for production environments? And I explained about most TTPs and adversaries are safe to execute on production environments. However, some TTPs that are not safe, we designate them as destructive. So
yes, actually, that's a great point. We can jump in. So there's something called tags, and we actually have one right here to what Chris was saying. So TTPs that would be dangerous to run in a production environment, we're going to label as destructive. Let's find one, for example, like deleting of a home directory. Obviously, that's destructive. So you'll notice this TTP doesn't actually have a deploy button up here. I have no way to run this. In order to run it, I have to explicitly enable it. And there's a button up here. So I would click enable. And that's going to prompt you to basically say, hey, I understand that this is bad. Deleting a home directory is bad. It has a destructive tag. It could cause potentially irreversible changes to the system. Are you sure you want to do this? Obviously, we default to no, so I'm going to keep it disabled. But let's say you want to build your own TTPs. All you would have to do is add that destructive tag, and that would essentially prevent anybody from using that TTP without explicitly going into editor and explicitly enabling it via this enable button. Now, once it's enabled, that means that the operator planning engine can go ahead and task that TTP if you've added it to an adversary profile. Hopefully that answers the question. Chris, were there any other questions before we continue on with the...
Nope.
Okay, all right, well, let's return. So again, I said I started a Netcat listener on port 4500. So what we could do, again, we were in our Windows range and we had some queued TTPs. And the one we wanted to try to unblock is this one. This one requires custom variables. It requires an IP and it requires a port. So coming back to this agent, we can click on this little icon up here, and then we can click on add row. And these are just key value pairs. So the variable is execution remote.ip. And thankfully, we have this provided here. We can see that the target we want is going to match this. So let me provide 192.168.127.1. So that has now provided the execution remote.ip. We also noted we needed a port. So I said I was starting a Netcat listener, and I just started it on port 4500. And that's basically all I need to add. And that will, once the planner refreshes, remote.port, execution.remote.port. Should task it. It's like it is not. There we go. So still saying that's queued. It's blocked by these, that's why. Okay, let's go ahead and clear that. And we'll just rerun the same chain. And let's get rid of the ones that didn't work for us. Looks like, oops. That would be why it killed our agent. I was wondering why it didn't work. Reconnect our agent. And then we're going to start from a fresh agent, so we can just click delete here. And then we want to re-add, because this is a different agent, we want to re-add our exfiltration information. So let's add the execution remote.ip. We'll add that up here. That's 192.168.127.1. Port 4500. And this would be how you would just add any kind of custom facts. So if you wanted to create a TTP that had any arbitrary fact, all you would need to do is specify it using that pound squiggly bracket with whatever text you would want to use inside of there. Again, we can click deploy, and that's going to go ahead and task that agent. And we can kind of monitor in the background, and we can see it's running a bunch of instructions. Oh, looks like that script has a small typo in it, but that's one that we can go ahead and adjust. And we'll take a look at how you would actually adjust payloads very quickly inside of Operator. It's actually very simple. So the point I want to show out of all of this, though, is if you note that create PowerCat has taken that execution.remote.ip and it's rendered it into this command, and it's taken that execution.remote.port and it's rendered it into the command based off the information that we provided in this fact modal. So you could provide any kind of facts, any fact key with any fact value, and this would be a way that you can provide kind of arbitrary information to an agent and let it achieve kind of arbitrary effects. But let's take a look at payload management real quick, because that's a common question. So we've noted that we had a small issue with this script. There seems to be a missing space between new object and NetWeb client. So how could we take a look at that? And we were using PowerCat. So over here on the right-hand side, you'll see a number of different options, and one of them is manage payloads. There are a few other ones like close TTP, attack chains. This is going to show you various kill chains. So we're talking about how you can build automated kill chains. Will show you different automations that you could use to put together based off TTP name. You can also export that TTP. So let's say you want to create one inside of Editor and then share it with someone or share it with your team. You could just click this export button. This will let you add a new TTP, which we will briefly do before we wrap up this workshop. This will let you import TTP files. So this is great. Let's say you have a team of 5 people and you all are going to be building your own TTPs for your organization related to your specific industry. What you can do is you can either provide a local directory path or you could provide a remote GitHub URL, and this will automatically import TTPs from that repository and then track any commits that are added to that particular repository. So this is a great way for you to have all of your stuff being built in version control and then automatically importing it into all of your teammates' operator instances. But we were talking about manage payloads. So if we come into manage payloads, what we'll see is we have all of the payloads available in our system and a couple different options. So we can, for example, download all payloads, and that's just going to populate all of these and make them all available to you locally. We also have Event Cleaner. But what's neat about this is you can actually click on it and you can see the contents of the script. For payloads that we provide to you, these are hard-coded. Sorry, non-editable, because we don't have a way to version control them. But you can see PowerCat. The full contents of PowerCat is available here. So we know there was an issue with our one TTP because it was trying to run a new object. So what we can do is we can find that line and go ahead and modify that TTP by adding it to the PowerCat TP, adding this new payload to that PowerCat TTP that we wrote. So let's go ahead and just grab all of this content. Grab all of this. And we'll copy it. Let's see what the what line we had that issue on. Oh, it's in the issue was in the actual TTP. Even better. So we can come to our basic adversary and we can take a look at this, and it just says we're missing a space here. We can click save, and let's go ahead and test deploy this against this. Looks like it might have. It says Defender is off. That is interesting. All right. Well, looks like that was the issue. There was missing a space here. So let's go ahead and test deploy it. As we had said, we can use this deploy modal over here to test run our TTP. And remember how we were saying you have to input the facts to that modal? If you're using the editor, it's actually going to prompt you to put in that those facts before you can actually run the TTP. So we can paste in our target and see if we get a different result this time. We'll click deploy. That looks like it did kill our NUMA agent again, despite Windows Defender being off. Deploy, and we can see if so. What we can see is I did in fact start that netcat listener, and that TTP did in fact run, and it sent to that netcat listener, and we can see that it matches who I am on that target system. So this would be a way. Let's say you want to like we did use PowerCat to throw a reverse shell connection back to your system. You could do it that way. And this is a great way to do like exfiltration if you just want to like send stuff to a netcat listener you have out on the internet. You could use that those variables and populate a fact and key value pair, and that would get rendered into the TTP. So what I will also show is really quick. If we go back, if you do want an interactive shell, let's clear that queue because that agent died. Chris had mentioned earlier that you can push this button up here. If you do that, it's actually going to task the agent to send a shell connection back, and this works cross-platform. So if I run this against a Windows system, obviously I'll get a PowerShell callback. If I run it against my Mac OS X agent, it's going to pass me back an actual PTY session so that I can interact with it. And as part of the system, again, everything is a TTP. So this is just a spawn reverse shell TTP that gets sent. So we've done a bunch of tests. We've run a bunch of tests. This one failed because we tried to run and install in the same location. We successfully ran our get keystrokes, ran some find recent files. All right, and now let's talk a little bit about the repetition side of this. So we ran that adversary profile actually a couple times. We ran it twice. Once against an agent. That agent got killed because of Windows Defender. And then we were like, okay, let's spawn it and run it again so that we can see that it's working. And then we found that it killed it one more time. So we actually ran the exact same test a third time and it connected. So this is actually a very good use case for us. It shows how easy it is to run the same thing over and over and over again. You don't have to have a whole lot of manual labor involved with applying the same kill chain end to end. You can just run that kill chain and then go do any IR or blue teaming that you need, and then run that kill chain again and see if you're able to grab more artifacts, see if you're able to grab more detections. So, as I promised, the most important part is generating lessons learned. So after you do the blue teaming side of this, after you do the incident analysis or incident response and analysis, what you want to do is actually begin to formulate a way to do the continuous defense evaluation process, and that is via a lesson learned. So when we call something a lesson learned, what we mean is uh, what did you do wrong, and then how can you change, or what was the root cause of what you did wrong, and then how can you prevent that from happening again in the future. So down at the bottom, you'll have this: in order to prevent Big Rock, which is the issue, which resulted from a root cause, next time we will do this. And tying this to operator, so you're going to run your kill chain. Let's say the kill chain runs end to end and nothing gets blocked. Well, what did you see on your side? What was the core issue that prevented you from stopping that kill chain? Let's say in this situation, you didn't have Windows Defender running. Okay, so that would be our root cause. So in order to prevent the adversary from running invoke Mimikatz and sending a power cat reverse shell back to the attacker system, which resulted from Windows Defender not being enabled, next time we will make sure we have group policies in place to enforce Windows Defender being enabled on systems. So you would generate this lesson learned via the process of a daily hot wash and create this formula. And then you would go back and you would run that kill chain again. Did that lesson learned that I generated and that fix action that I created actually stop that kill chain from running end to end? If it did, that's great. Now you can get more granular. So we stopped the invoke Mimikatz and we stopped the power cats components, but we didn't stop the finding of recent files. We didn't stop the staging of files, and we didn't stop the exfiltration. What would be the root cause of that? Maybe your network intrusion detection system or your data loss prevention suite didn't actually successfully detect the file.io data exfiltration component of this particular kill chain. So next time, how would you, what was the root cause? So your root cause was that, and then how would you fix that? Apply that fix, and then go run the kill chain again. Did you detect that file.io data exfiltration? And using that process, you can repeat until you're able to detect the components of that attack and prevent the kill chain from going end to end. So some key points here: repetition is very important. And the way you improve your security operations in general and the way you do that continuous defense evaluation using adversary emulation platforms is by running an operation and exercising your processes, and then honestly assessing how well or not well you actually detected those automated kill chains. Then run those evaluations daily, run them weekly, and continually tweak and improve in very small ways your defenses so that you can pick up more of these kill chain components. And when I say kill chain components, again, I'm talking about these TTPs. So maybe maybe you don't detect any of these attacks individually, but when they're all added into a kill chain and run in a sequence, you are able to detect it. So how could you get to a more granular level of detection? And using operator, you can kind of repeat the same kill chain over and over until you are able to detect those components. All right. So I think that was a lot of content very fast, and I think we're coming up on 20 minutes left. So I'm going to pause here for any questions that people might have, or pretty much anything across the board. And also let Chris, if you have any questions from the crowd.
Currently, there's nothing in the conference chat. So just to let everyone know who may have came in late, I am monitoring the chat on twitch.tv as well. I can't post in there, but if people have questions, I can see the stream chat and can talk about it here.
All right. Since we do have a little bit of time left, for the people who have AWS, I can really quickly show you how you would actually use that component. And the way you would do that is by coming over to the plugin section and installing the cloud plugin. So the cloud plugin will let you select your desired service. So we support AWS and we support GCP. But for AWS, basically what you would want to do is provide your AWS credentials. And your AWS secret key, and then a path to an SSH key, and then you would click save. So I pushed an update specifically for this workshop to our cloud plugin that added regional support. The backend server side of this is going out today, our time. So in a few hours, 4 hours from now is when the backend component of this will be available. If you want to use this right now, use the US East 1 region until later today, at which point all of these regions will be supported. Click save and jump in. So when you jump into here, you will have the option to deploy redirectors, Linux servers, and Windows servers, as well as a deep learning environment. But what we want is a redirector. And I'm going to go ahead and install HA proxy on that as well. So I think HA proxy is community. Chris, can you confirm that? I think I added that.
Check.
No, it won't be. So
Yeah.
do disabled. So when I click deploy, what's happening in the background here? So I click deploy. We're actually going into EC2 on your account that you created. And we're going to go ahead and provision just a very small free tier instance, a T2 micro free tier instance. And that free instance will be available to operator so you can make agents connect over the internet. And that's what we'll show. Next to, if you go back to the operate section, after you click on the deploy, you will have this little icon to the left, which is configure redirectors. And when you click on that, it's going to bring up a side modal. That side modal will have a orange little dot, which is essentially indicating it's waiting for that redirector to be live. And it takes a little bit of time for the server to turn on. But once it does, you'll notice the dot will go gray, which means that it's been able to successfully test a connection. And then I can click connect, and it will connect to the system. So what that means now is I can actually, instead of connecting over localhost, let's come back to our NUMA Darwin agent. I can connect my NUMA Darwin agent to this EC2 address instead. And then, still taking a second for it to turn on. And I have now connected my agent over the internet, so I've exposed that redirector to the internet. So if I wanted to do more realistic campaigns as opposed to running a campaign from inside a adversary network or inside my own industry network, I could instead spin up several redirectors just by coming into plugins and clicking the deploy button. And then I would have, I could spin up maybe 5 instances of redirectors and make those available. Just click deploy one more time. And then I would have 3 redirectors now available on the internet that I could connect my agents to, maybe one over HTTP, maybe one over TCP. And you can mix and match and play with it that way. You also, via that cloud plugin, have the ability to provision Linux servers. And when you provision a Linux server, it's going to automatically install a NUMA agent on it and connect that NUMA agent back to operator over the internet. And what that'll let you do is from that NUMA agent running out on the internet, you can now launch TTPs like nmapping their external network, setting up proxy chains, maybe installing a Chisel server, and then having a Chisel server client connect to the Chisel server running in the internet. Basically, get as creative as you would want when it comes to that side of things. Okay. So while we're waiting for the rest of these to connect, you can see I can now connect to all 3. So I now have 3 different redirectors all connected to operator. I could connect agents to any of these 3 and they'll just kind of seamlessly integrate. So you could control 4 different agents in a target network, just all connected to 4 different redirectors if that was your chosen method. And again, this is just for people who went through the process of setting up an AWS account for this workshop. And eventually, we'll get a connection back from our cloud range. So you can see it, when that Linux server provisioned, the one that we ran via the cloud plugin, it created that Linux server, installed a NUMA agent, and it connected back on the cloud range. So I can use this cloud range now as like a fleet of initial access servers, for lack of a better word. So I can run like nmap scans, I guess I'd said, against a target. I can also, drop into my shell on that EC2 server and do whatever I would need to from there. So that pretty much wraps up the talk. I will pull up our contact info page. That's the workshop today. I know we covered a whole lot of content, everything from the basics of the various tabs of operator to how you would actually, at a very basic level, go to the CISA alerts page, extract some kind of relevant tactical information related to your industry, related to your a particular organization, implement or find those TTPs and add them to an adversary profile in Operator, and then go ahead and actually deploy and run those against a target system. From there, we talked a little bit about how you could add custom variables and do more advanced stuff like setting up a netcat listener and having the agent use PowerCat to send you a shell. We also dove a little bit into the cloud plugin, which allows you to do external attacks and actually have agents connect over the internet back to your desktop C2 platform. So I will pause there. I'm going to start disconnecting these redirectors. And we will hang out for the remainder of the 10 minutes on this workshop call and address any questions or go through any topics that people might have additional questions, comments, or thoughts on. But thank you, everybody, for coming to our talk today. I'll leave up our contact information. If you want to reach out to us on any of these. Chris, did you drop the Discord link in the live chat?
I can.
Can you drop the Discord link in the live chat? And then if you need anything, reach out to us either on one of the various platforms, Twitter, GitHub. You can email us directly, or you can hit us up on our Discord. But we're here to help. Again, prelude.org to download this for free. Everything we showed today, you can just download for free and start using. And if you have any questions, again, hit us up on Discord and we can help you get started. Looks like there are no questions. So thanks again, everybody. Yeah, if you have any questions that you want to ask us directly, again, just shoot us a message. We're super available. We're here to help, and we're happy to if you want to hop on a like a one-on-one Zoom call or something, and you want to talk more about this or whatever. Definitely, please reach out. We're here to help.
Yeah, and Alex, just so to push this a little bit, so we also have a podcast that we do once a month that is on Spotify and Apple Podcasts, as well as some other podcast distribution sites. And then we also do Twitch streams every month. So we just did a Twitch stream just 2 days ago, and so we record those and. We also record those and put them on YouTube. So we're doing a lot of stuff. So
awesome. Yeah, we will do that. Great. Thanks, everybody. And hope you learned something. Please reach out.